Hello, 107 students. We're back to talk about the atom. So here's a representation of an atom, and it's a pretty good one. Let's see what you know. In the middle of the atom, we have some orange and blue particles, subatomic particles. Do you know what particles are in the middle of an atom? You are correct if you said protons. Do you know the other one? You are correct if you said neutrons. Protons and neutrons live in the middle of an atom, and that's called the nucleus. Now, all the mass of the atom is in the nucleus because the protons and the neutrons are the biggest particles in the atom. Then there's particles going around the outside of the atom. Do you know what those are called? Yeah, those are called electrons. But according to this picture, they're as big as protons and neutrons, and that's wrong. So electrons are actually almost 2,000 times smaller than protons and neutrons. So technically in this picture, we shouldn't even see the electrons. So proton, neutron, tiny electron. Electrons are tiny and have almost no mass. But protons and neutrons are in the nucleus, and electrons go around the outside of the atom. So here's a table of our subatomic particles. The electron is symbolized with the lowercase e negative sign. It's outside the nucleus, and the negative is because the charge is -1. The relative mass in atomic mass units, AMU is the unit, atomic mass unit, is 1,836 times smaller than a proton or neutron, meaning it's basically zero. It's so small. Remember I said electrons were tiny. So their mass is basically zero. It's negligible. Kind of like if you went to give your landlord a penny. Landlord's not going to take a penny for your rent. It's negligible. It's basically zero. The mass of an electron is basically zero. Now, protons are symbolized with the lowercase p with a plus sign. They're inside the nucleus, and the plus sign means protons are a +1 charge. Their mass is 1 AMU, atomic mass unit. Neutrons are symbolized with the lowercase n with no charge. They are inside the nucleus, and they have no charge, meaning zero or neutral. Their relative mass is like the proton, 1 AMU, atomic mass unit. So again, the mass of an atom depends on protons and neutrons because electrons are basically zero. Some facts about atoms. Atoms are neutral. So the positive protons and the negative electrons have to cancel out and be equal to each other. In other words, if we have 3 protons in an atom, we need 3 electrons, so they'll cancel out and be neutral. Now, the number of neutrons can vary. So we can't predict that by looking at the periodic table. There are 2 numbers you need to know about an atom. The mass number is what has mass, protons plus neutrons. So the mass number is the number of protons plus the neutrons together, and that's the mass of the atom. The atomic number is the number of protons only, and that can be found in the periodic table. For example, hydrogen, element 1. The number 1 is the proton number. Hydrogen has 1 proton. The number 1's right above the H. 1 proton. Carbon, C for carbon. Look above it, 6. 6 protons for carbon. Oxygen, O. Look above it, 8. 8 protons. So those are the atomic number. The number of protons is the atomic number. So if I give you the mass number, which is protons and neutrons together, and then I give you the atomic number, which is the protons only, how can you figure out the neutrons? And you're correct if you said subtract. Yeah, you subtract. The number of neutrons is your mass minus the protons, which is the atomic number. So mass number minus atomic number. Mass minus protons will give you your neutrons. Atomic notation. So atomic notation is how we would write the notation of an atom on a piece of paper. It's not how it appears in the periodic table. It's different. In an atomic notation, the mass number is at the upper left, and the atomic number or proton number is lower left. And then the symbol N stands for nitrogen. So we put the numbers on the left side of the nitrogen, N, and the top number is mass, the bottom number is the protons. Now, where do you get the mass number from? Well, I say it like when I say carbon 12, the number 12 is the mass number. In other words, 12 is protons plus neutrons. This would be nitrogen 14. 14 is protons plus neutrons. So, where'd we get the 7? Again, we go to our periodic table for the protons. Nitrogen is number 7. So 7 protons. So you get the proton number, I give you the mass number. And then we write it like this because we can subtract easily to get the neutrons. 14 minus 7 equals 7 neutrons. So atomic notation is something you should be able to write, and I may have a file upload question. So again, put the symbol, and then the upper left number is the mass number that I give you. Lower number you figure out from the periodic table. It's the number of protons, the atomic number. Okay, good luck with that. So I have some questions for you. How many protons, neutrons, and electrons are in these atoms? Carbon dash 13, it's not a minus sign, it's a dash. Oxygen 17, sodium 23, chlorine 37. Now remember, that number after the dash is the mass. Protons plus neutrons together. Let's do the carbon one together. So the mass is 13. Let's figure out the protons by going to the table. Carbon is C, C is 6, 6 is protons. So carbon 13 has 6 protons. Now remember, for an atom, protons and electrons are equal. They have to cancel out. So we also have 6 electrons. Now how do we figure out the neutrons again? We subtract. 13 minus 6 is 7. 7 neutrons. So carbon 13 has 6 protons, 6 electrons, and 7 neutrons. Now you hit pause and try the other 3. Okay, oxygen 17. 17 is the mass. Oxygen is O. O is number 8. So 8 protons, 8 electrons. 17 minus 8 is 9 neutrons. Sodium 23. Sodium is in the first column, Na. Says right there, sodium. Na. Na is number 11. 11 protons, 11 electrons. 23 minus 11 is 12 neutrons. Chlorine is Cl, second to last column. Cl is number 17. 17 protons, 17 electrons. 37 minus 17 is 20 neutrons. Let's check our answers. Carbon 13, 6 protons, 6 electrons, and subtract to get the 7 neutrons. Good job. Oxygen 17, 8 protons, 8 electrons. Subtract, 17 minus 8 is 9 neutrons. Sodium 23, 11 protons, 11 electrons. Subtract, 23 minus 11 is 12 neutrons. And chlorine 37, 17 protons, 17 electrons. Subtract, 37 minus 17 is 20 neutrons. All right, we're going to stop there for this video. Good job. We know how to calculate protons, neutrons, and electrons, and that's hugely important. So review this question over if you need to. All right, bye-bye.